This is the first part of lesson 3.3 on multiplying two binomials. This is really, really important. This is a skill you're going to need a lot. Okay, so in the first part of this video, in part A, we're going to look at multiplying binomials using algebra tiles and using a rectangle diagram. Sometimes it's called an area diagram or an area model, a rectangle model. But we're going to start with the algebra tiles. So as usual, we're just going to draw in the tiles, keeping the gaps that we, where there's a gap, there's a gap here, it needs to continue all the way through. So we're going to just fill this in. These are terrible drawings for me. Oh, it's because I'm doing it with my right hand. It's really funny. There's things that I do with the mouse with my right hand because, I mouse with my right hand. But there's some things, sorry. There's some things that are just really hard to do with my right hand. But mousing with my left hand is really, really hard. So, weirdness. Yes. Okay. I have to try the next one with my other hand. This is funny. Okay, so as you can see, there's a gap that goes all the way through here. There's a gap that goes all the way through here, a gap down here and up here and down here. Okay, now that we've got the shapes in, we need to decide what we're coloring in. And because all of these are positive, all the results are going to be positive. So I'm just going to do that with magic. Ta-da! So now we're going to look at what was our result. So we multiplied x plus 3, that's across the top, by x plus 2. And a result is, if we look in the middle, we got an x squared. And we got 1, 2, 3, 4, 5 x's. And we got 6 ones. So there's our result. Okay. Over on this side, we are going to multiply x plus 4 times 2x plus 1. Now, does it matter which one you put across and which one you put down? Not at all. I generally put the one that's going to take up more space across the top just because it takes up less paper that way, but it doesn't matter at all. But I did figure out why I was having such a hard time drawing those things, and it's because I was doing it with my mouse instead of my stylus. Yeah, gonna be a good day. So I'm just gonna pause the recording while I fill this in, and you fill it in, and you can check what you get at the end, okay? Well, I wouldn't say I did a good job or a great job, but I did a better job. At least the lines are straight-ish, better than the first time. Anyway, this time what we have is we have 2x squared plus 1, 2, 3, 4, 5, 6, 7, 8, 9 x's plus 4 ones. So there's our result, okay? This is more of the same, just paying attention to whether things are positive or negative. So again, I'm going to pause and do, we can fill in this top part here. So this is going to be x minus 3, right? 1, 2, 3. And this side is x minus 2. So go ahead and pause the video and fill that in yourself. And check your results. So here are our shapes, and when we go to color them in, we see that we've got a positive times a positive, so we have a positive x squared. And then these are all going to be negative, these x's, and these x's are going to be negative, but our ones are all going to be positive because they're all created from a negative times a negative. So our result is going to be x squared minus 1, 2, 3, 4, 5 minus 5x plus 6. Okay, one more. Go ahead and do it. Okay, so there's our shapes. These are all going to be positive. This column is going to be positive and the next column is going to be positive. If you glossed over this and didn't actually fill these in, please do. These drawings are actually going to be, they're going to be relevant in the next half of the lesson, okay? Yeah, they actually have meaning here. I forgot to do this, so this is going to be 2x minus 1 times x plus 2 gets me 2x squared. And this time we have 1, 2, 3, 4 minus 1. So that's going to be 3 x's in aggregate, because these, like this one, will cancel out one of the positive ones. And then minus 2. All right. Okay. Now we're going to look at an area diagram. And an area diagram, actually, these are not correctly called area diagrams. These are rectangle diagrams or rectangle models, because an area diagram can't have any negatives. So this one can be an area diagram because this is something, this is plus 3 and this is plus 2. If we do this, it can't actually call it an area diagram because you have a negative area and that's not a real thing. But we'll call it a rectangle diagram or rectangle model. Anyway, what I'm going to do is I'm going to draw a rectangle. Oh, actually, we're going to do the bottom part of this page first because that makes more sense. Okay, so let's look at this one. If we did 32 times 34 and we did long multiplication, we get 1088. If we do it as an area diagram or rectangle model, we take the 30 and we split it up, or 32, and we split it into 30 plus 2, and we take the 34 and we make it 30 and 4. Then we can just do these little pieces of multiplication, which is much easier. 30 times 30 is 900. 2 times 30 is 60. 30 times 4 is 120. And 2 times 4 is 8. And we just add all those pieces up and we get the same answer, which is actually pretty cool. So let's do these ones. So I'm going to make, this is going to go, and you know, you can try and make it sort of ish. You're not going to make it to scale. It's not going to work. Oops, so that's 50 and that's 1 and that's 40 and that's 3. So this part is going to be 5 times 4 is 20 and then add 2 zeros. So that's 2,000. 1 times 40 is 40. 3 times 50, you go 3 times 5 is 15 and then add that 0. So that's 150. And then this is 3. And then if I go 2,000 plus 150 plus 40 plus 1 and I add all that together, I get 1912. And if you take out your calculator, you'll find that that is the correct answer. Wait. How did I get a 1 there? That was supposed to be a 3. Oh, yeah, that's supposed to be a 3, and that's a 3. I'm sorry, my bad. 2193. Okay, and then let's do this one. Actually, I'm going to get you to do this one on your own, and then check your answer. Okay. Okay, so hopefully you got that, and if you check it with your calculator, that is the right answer. So that's a really quick way to do multiplication, and since we know that it works for numbers where we know what the answer needs to be, we're going to extend this and do it up here for polynomials, or specifically binomials. So in example A here, I'm going to make this 5x and -6 and 2x plus or and 1. So then I'm just going to do the product of each little square. I've got 5 times 2 is 10, and x times x is x squared. -2 times 6 is -12 times x, and this is going to be 5x, and this is -6. So this equals, oh, sorry, this is, yeah, sorry. We got 10x squared minus 12x plus 5x, that's going to be minus 7x minus 6. So that's what the answer needs to be. Okay. This one, we'll do the same thing. I'm going to draw it over here where there's a little bit more space. I have a squared and minus 8 and a squared and minus 5. So this is going to be a to the 4 minus 8a squared minus 5a squared and positive 40 or plus 40. So this equals a to the 4 minus 13a squared plus 40. That's my product when I multiply those two things together. Okay, I'm going to pause it, give you a chance to do one on your own, okay? Okay, so when I multiply that out, I get 3q squared plus 29pq, because there's 27 plus 2 of them, and then 18q squared. And finally, do this last one, okay? Okay, so you should get AC plus BC plus AD plus BD, all right? Does the order matter? Not really. The order for the other ones, the order does matter because we always do these things in lowest in decreasing degree. So we start with the squared term, and then we go to the where that like this is p squared, so this is just p to the 1, and the q just tags along, and then there's p to the 0 in this one, so that's why we do that in this order. This one, it's not really clear what order is, but it is convention that within each pair of letters we do put them alphabetically. That's just a convention so that they look similar. It's easier to find like terms if things are the same. Okay, go ahead and do questions 1 to 3, and then come back for the last page of notes in the second part of the video. All right, bye.